Alright, hello again everyone. I want to thank you very much for your work over the last couple of days. I really appreciate it. So today we're skipping ahead to 8.4, multiply and divide rational expressions, day 1. We're going to split this up into pieces over the next couple of days. So starting here with example 1, a standard fraction rational number, one that you've worked with for a while. Just want to kind of remind, when we simplify fractions, one way to think about it is that we are factoring the numerator. So I can think of 21 as 3 times 7, and then factoring the denominator, I can think of 28 as 4 times 7, and then we look to cancel any common factors, as long as everything's connected by multiplication. So the 7 up top and the 7 down below, 7 divided by 7 is 1, they cancel each other, and of course that's how we come to an answer of 3/4 for that problem. So now we want to think similarly for number 2, which you now see has variables and polynomials. And I'm looking first to factor the numerator. I'm looking for a product of negative 15. I'm thinking one has to be positive, one has to be negative. And then over here, a sum of negative 2 tells me the negative is stronger. So I'm right away thinking of the numbers 5 and 3, like x minus 5 and x plus 3. There's the negative 5 times 3 makes negative 15, while negative 5 plus 3 makes negative 2. In the denominator, I notice the middle term is missing, so I'm thinking of a difference of 2 squares where I have opposite factors, and that's what made the middle cancel. So I'm looking at 9 as a perfect square with 3 and 3, but I need one positive and one negative. So like x plus 3 and x minus 3. So now I'm looking for any factors that might cancel each other. And they don't have to be right on top of each other. It's all multiplication. We could switch the order if we wanted. So this x plus 3 over here and this x plus 3 down here, they in fact cancel each other. And that leaves me with an x minus 5 in the top and an x minus 3 in the bottom. So final answer there, x minus 5 divided by x minus 3. And then let's go ahead and take a look at one last example for today. That's example 3 here. 2x squared plus 10x in the numerator and 3x squared plus 16x plus 5 in the denominator. So first thing I notice about the numerator is there's a GCF. I see 2 and 10 are both even. I also see some x's here and another x there. So I can pull a 2x out of everything up there. If the 2 comes out and one of the x's comes out, it just leaves behind an x. And I'm looking at 2 times something makes 10, so I know I need a positive 5 right there. And in fact, that's all I need, because the x is already there. So now I look to the denominator, and I'm factoring that. I notice the a value here is 3, so I might think back to the AC method. And I'm looking at factors of a, like 3x and 1x. And then I'm looking at factors of c, like 1 and 5 or 5 and 1. And I put my factors of c here. Remember, you can use a diagonal to check and see that would be 3x, that would be 5x, 3x and 5x would make 8x, and that means that's not us. So I'm going to try again here. And I like to keep the a values locked in place and then just switch the c's around. So now I'm going to go with 1 and 5. That one gives me 15x. Then that one gives me 1x. So 15x and 1x does make 16x. We've got a winner. So remember, the factors we're looking for are the horizontal pairs right here. That would be 3x plus 1. And then 1x plus 5, or just x plus 5. So then at that point, we do have a couple of common factors here. The x plus 5 in top, the x plus 5 in the bottom. And leaves us with 2x divided by 3x plus 1 for our final answer. If you have any questions, of course, be sure to email me. Go ahead now and work on the assignment for today. And thank you very much. Appreciate it.